Okay, so we've seen what PowerShell is capable of. Now it's time to dive into the nuts and bolts and talk about some of the basics of PowerShell. We will learn about some of the commandlets that make it up and how these differ from command line executables from the DOS prompt. A commandlet is a lightweight command that is used in the Windows PowerShell environment. The Windows PowerShell runtime invokes these commandlets within the context of automation scripts that are provided at the command line. The Windows PowerShell runtime also invokes them programmatically through Windows PowerShell APIs. Commandlets perform an action and typically return a Microsoft.NET Framework object to the next command in the pipeline. Commandlets differ from commands in other shell command environments in the following ways. Commandlets are instances of .NET Framework classes. They are not standalone executables. Commandlets can be created from as few as a dozen lines of code. Commandlets do not generally do their own parsing, error presentation, or output formatting. Parsing, error presentation, and output formatting are handled by the Windows PowerShell runtime. Commandlets process input objects from the pipeline rather than from streams of text, and commandlets typically deliver objects as output to the pipeline. Commandlets are record-orientated because they process a single object at a time. Let's start with some basics. The get command is one of the most useful commandlets in the whole of PowerShell, as it will help you getting to grips with PowerShell by letting you search for certain commandlets. Using get command on its own is admittedly not a very useful tool, as it's just going to spit out every command that PowerShell has. But from this, we can see that objects that PowerShell outputs have both a name and a module name property. Using this information, we can fine-grain our search by searching for commandlets that contain certain terms. For example, if I wanted to find all the commandlets that contain the word IP, I could do this. As you can see, we still get quite a few results. Our next option is to search within a specific module. In our case, I will choose the NetTCP/IP module. Once you have found the commandlet you are looking for using get command, you're going to want to know the syntax and how you can use that specific commandlet. This is where get help comes in. By using get help and passing the commandlet's name to the get help commandlet as a parameter, you'll get output to the screen the syntax and any variations of what the commandlet can accept. Piping is another key feature of PowerShell, and we'll be using the getMember commandlet as an example. GetMember allows us to get information about the objects that a commandlet returns. The catch with GetMember is that it relies on PowerShell's pipeline feature. To demonstrate this, we can use the getProcess commandlet. As you can see, PowerShell's output shows us some of the properties which you can see at the top of each column. The first problem is that while those are the properties you might be looking for most of the time, there are still more of them. The second problem is that it doesn't show any methods that we were able to call on the object. To see the methods and properties, we can pipe our output to getMember like so. So now you have learned how to use a pipe with the getMember method against the getProcess commandlet. For example, using the information from the getMember output, we could do something like the script shown here. The .NET developers out there might recognize the wait for exit method as being the standard method on a systems diagnostics.process class. Best of all, these commandlets can be distributed. Using the common information model to run commands on remote systems and to administer various systems in a heterogeneous environment. This is because the CIM commandlets adhere to the CIM and the WSMan standards that are defined by the Distributed Management Task Force. One thing to keep in mind is that Windows PowerShell is a .NET Framework application. As such, any user can use Windows PowerShell to perform whatever actions they would have the ability to do. Therefore, Windows PowerShell is not a super tool. If, for example, a user does not have the rights to manage printers or to install device drivers, that user cannot run a script that manages printers or installs those device drivers. A user can only do what a user has the ability to do.
Created using Powtoon.